Profit Maximization, Part 2. So yesterday we created, using some hypothetical data, some cost curves for Hungry Howie's Pizza. So we created a curve for the average total cost, the average variable cost, and the marginal cost. And as we said, we got these different cost curves that the marginal cost intersected the average total cost and the average variable cost at their lowest points. Now, the question we really need to ask ourselves is, how much should a firm produce to maximize profit? And if we look at this graph, if we know our market price is $4 because that's what we as perfect competition competitive firm, we don't really get to choose our prices, and so if we look at that, we have to go, okay, at what point do I produce? And it's tempting to say that, oh well, this point right here where it intersects, that's my lowest average total cost, so my average cost per pizza is the lowest there, and so my margin, my profit margin, is by far the highest. And my profit then could be kind of summarized as, well, this is my quantity times my profit margin, how much I would make if I was selling, let's see, what would that be, about 225 pizzas. But the reality is that my best spot to sell, even though it's not my highest profit margin, is where my price intersects my marginal cost. And my profit per pizza has become a little bit smaller, but my overall revenue, as signified by this rectangle, is a lot larger. And it makes sense, after this point on my graph, the cost of producing, the marginal cost, the cost of producing one more pizza is higher than the price I'm able to sell it for. But up until that point, I can make additional profit by selling a pizza. It might cost me $3.80 or $3.90 to make the pizza because my marginal costs are going up, and I can only sell it for $4, but that's still a 10 or 20 cent profit, so it's worth it to me. We can also then show that in our data. Let me get this graph out of our way here. We can show that in our data if we create another column here called profit. I'm going to call it profit, if I can type it, at $4. So my profit at $4, it equals the total quantity that I'm producing, the number of pizzas, times, and then I have to do quantity of my price, which is 4, minus my cost per pizza, my average total cost per pizza. If I do that, I get a negative number, and it makes sense. I'm selling at a loss. If I only produce 50 pizzas, I'm going to have a $100 loss. But now I can click and drag that formula down, and I'll quickly see that my highest profitability comes somewhere between 300 and 350 pizzas produced. So that peak point is somewhere in between those. And lo and behold, if you look at our marginal cost is $4 at 325 pizzas. So that would be my profit maximization point. And actually I could calculate that, and my profit maximization would be, I think it's around $403 or something. So my optimal output is about 325 pizzas. So the answer to how much a firm should produce is always, as long as there's perfect competition, the answer is always until the price equals marginal cost. Well, what about the case when there's not perfect competition? What about the case when we have a monopoly? In a monopoly, unlike in the case of perfect competition, the firm can really choose what price it wants to sell. You can actually think of the marginal cost curve, because this is the only supplier. This is essentially the supply curve, this marginal cost curve, and in theory we'd still reach that equilibrium price. So I took this Hungry Howie's graph that we had, and I put in a hypothetical demand curve that's sloping downward. And again, in perfect competition, we would produce at this point where the curve hits marginal cost. But the reality is, for a monopoly, if this is the price that we would expect them to charge, because that's the market equilibrium, and I'm going to draw on this rectangle to kind of represent their profit, this might not be their point of highest profit. In fact, it most likely isn't their point of highest profit. In this case, we might have a point somewhere out here with a higher margin, where even though the quantity we sell is a little bit less, the overall profit might be a little bit bigger. And this magenta box now might represent a larger profit. You know, if our goal in our economy is to have perfect competition, well, the government might not like a monopoly. It means there's higher prices, and it means there's lower quantities of goods being produced. So the government kind of fights that. Now, I went ahead and that demand curve, I had inputted that data, and I calculated the profit, and as we can see, the profit actually does peak somewhere around the point where the price is $5. So yeah, a monopoly ruins this idea of perfect competition. But I'll stress one more time, in the case of perfect competition, when we're modeling that, a firm that's trying to maximize profit should always produce until their price equals their marginal cost.